Thanks so much for the introduction. Thank you all for taking some time off your busy day to join us here. We're going to take a walk through what COVID is doing for us and what it has done to our lives and how it is shaping lives around the world through the eyes of Tableau. Right? So to get started, if you want to go over to Google Drive, there's a bunch of files out there, including the PDF I'll kind of be reviewing here. There are also a couple of data files should you decide to go through with the work along option. So without much more ado, let's get right into this thing. I see this, so many of you probably heard this, but you know, COVID has made us socially distant, but we don't have to be socially awkward. So if we can't see each other, then it's the socially awkward part. Okay. Great. So we can kind of like look around and just get familiar with all the other folks around us. We're all locked up in our little cubbyhole apartments, like Governor Andrew Cuomo said. Some of us suffering cabin fever. Some of us have you know, friendly companions, pups, dogs, cats, pillows, mugs, and maybe you can just show them off here, so everybody else can get to know each other, each one of us really well. Or if you're like one of my students who contacted me and insisted she couldn't come on camera because she was in her pajamas. I asked her, well, you know, it must be late, where you must be in China, because it was 2 o'clock here. It's like, no, I'm in New York. Well, I guess we're all very comfortable right now being at home. There's some good things going for us with COVID-19, believe it or not. So with that said, let's just jump right into this thing. I want to give you a quite a quick fire tour. So without much more ado, I'm a professor here. I teach a bunch of marketing analytics courses at Pace. George has already spoken about that. So a bit about the logistics of how we're going to go through this thing. I'm assuming that all of you joining us here have, you know, little or even no experience whatsoever. You've probably heard of Tableau for the first time, and that's perfectly fine. There might be some of you who are more experienced than others, and if that's the case, then there will be something for you also as we go through this this session. You have the option of, if you feel uncomfortable, just kind of watching along all the nifty things that Tableau can accomplish for us, and all that we can learn about COVID-19. Or you can work along with us. So whichever you decide to do. We're going to start out really slow, and right around the right after the first quarter, we get in the second quarter of the football game. We're going to pick up some tempo, and we'll be really flying through it in the fourth quarter. Okay, so bear that in mind in terms of you know, speed. We're going to start out with some very basic elementary topics, which might be for those of you really experienced, it might be you know, a bit of a yawn session. But don't worry, in about when you get to Q2 or Q3, things will pick up a little bit, so you might be a bit more into the more advanced topics by then. All the data sets that we're going to use are open data sets. They're all available from either Johns Hopkins or Apple or Google, and that's where I procured the data sets from. They weren't available before because they're really hot off the press, so to speak here. They are literally updated by the day. So those are fresh data sets that weren't updated until 4 o'clock this morning in some cases. And in some cases, unfortunately, they weren't updated at all. So we have yesterday's data instead of today's data, which is unfortunate. You'll see that. On with it then. Dataviz is the use of visual representations to explore, make sense of, and communicate data, as expressed by Stephen Few. Now, one question that I'm often asked is, you know, why in the world should you visualize data? Especially those of you who know about me, I live and die by numbers. I don't die, I live. I live and thrive by numbers. I'm still breathing. Why should somebody like me, you know, talk about visualizing stuff when, you know, numbers are golden? Well, it turns out that even the smartest mathematicians, which I'm not, in the world, believe that pictures can tell a story that numbers cannot. In fact, most of us, no matter how quantitative, will respond more quickly to a picture or a chart than to numbers. It might have something to do with our evolutionary backgrounds. As Neanderthals in the forests faced by predators like tigers or lions or whatever creatures they had back then, when faced with an encounter with a wild animal, one is not going to stop to compute the velocity of the attack, the trajectory of the pounce, or the impact it's going to have on one if it were to fall upon us. The smartest mathematical minds in the world are going to do what they're trained to do evolutionarily: turn around and run. We respond very quickly to moving objects, to things that are, again, visual, right? So in general, John Tukey said this very aptly many, many years ago, which is that a picture is not merely 1,000 words, but is much more likely to be scrutinized than words are to be read. You've got a spreadsheet on the left and a bar chart on the right. I bet you a Fields medalist would rather look at the stuff on the right because it has more resonance than what's on the left. If you want to see the big picture, a chart is golden. If you're thinking about identifying patterns, you can look at numbers on the left and look for ups and downs. But on the right, you can see seasonality a lot better in the blue line. The green line shows you an outlier sometime in August. The numbers on the left are the same information, but harder to parse. And finally, visualizations or charts work by complementing what sophisticated analysis can yield. So sometimes looking at data through a chart, through a graph, through time series charts and so on, can tell us something that the statistics won't give us. Take my word for that. There's a nice little Enscombe quartet story that, of course, you can look up on Wikipedia if you're not convinced about what I'm saying. Now, visualizations aren't new. We've been making graphs and charts for many, many years. So obviously the question is, why do we call it visualizations? Well, it's a catchy word, that's why. You can call it a graph, you can call it a chart, you can call it a fancy chart. Visualizations sounds cool. And that's one reason why the name is caught on. What's important to note here is that the difference is, and probably the reason and motivation for the new label is, that we're doing this a lot better than before. We're making more compelling graphs, more compelling charts. Excel was good, but D3 is much better. Seaborn from Python makes great visualizations as well. So the visualizations of today have moved far beyond the classic bar, line, and pie charts of the past. In fact, mentioning pie chart today is going to make some hairs, stand up, because people don't want to hear the use of pie charts just because they're uniformly disliked by scores of people. There's a lot of software. There are a lot of software out there that can enable us to construct great charts. Again, some like D3, Python, R, Tableau, SAS, ClickSense, and so on. Some involve the use of many-driven software. Tableau is one of those. Then there's the ones that involve code. I mentioned D3 before. R, Python, all of these involve using code to put together charts. If you like poking around menus and dragging and dropping boxes, Tableau is the right thing for you. There are other options like SAS Visual Analytics, but I believe Tableau offers us the best value. There are many flavors of Tableau. Tableau Public is one that is free forever. Anybody can download a copy of Tableau Public, use it, spin together business, and push it to the cloud. But they may not save it to their own computer. So with free comes a catch, and that's the one for Tableau Public. With Tableau Desktop, it is the full-blown version of Tableau with all the bells and whistles of Tableau. It can do a lot of amazing things. As a student, you get a year of license for free once you're, again, verified by Tableau, should they ask you for verification. Tableau Reader is meant for people who want to see your visualizations, but does not have the ability to edit, or Tableau Reader does not have the ability to edit a viz. Tableau Online and Tableau Server are company or enterprise solutions. One is cloud-based, managed by Tableau, called Tableau Online. The other one is on-premise, sort of managed by the client, and that's called Tableau Server. I'm assuming those of you who want to follow along have downloaded something that looks like what's on screen right now. That's the Tableau start page. So I'm going to walk over right now to my my Tableau version out here to kickstart that. Okay. So here is coming up is my Tableau version, and while I do that, you can do the same thing as well. Right. So hopefully you've had the time now to pull up that the Tableau software. Here is my version of Tableau that's pulled up. And I'm also going to kind of toggle to a different window to highlight here again the files we're going to use. The slides I'm reviewing are right here on the Google Drive share. We also have a couple of data sets out here, including information about what COVID has done to our lives. The data on confirmed COVID cases, deaths, both in the US and globally. This is procured by Johns Hopkins, taken from the GitHub page. So thanks to them, and thanks to GitHub for hosting it. Apple has shared some data with us, and so has Google, and we have those data sets on Google Drive as well. Again, these are open sources. Anybody can pull them, and they're updated quite frequently. The ones by Johns Hopkins are updated every day at about 4 o'clock in the morning. So they're really fresh. Okay, so if you're on this page, I'm going to hit the pause button and make sure you're all on this page. And if you have any questions, not sure about something, I'm going to take a question or two at this stage if you're stuck. All right, great. We're going to have a guest lecturer come out here. My son is going to grab something from the printer, and he's going to show his face.
Hi.
Great. Okay, now you're going to grab your fridge. Okay, and now he's going to leave after sharing his thoughts, right? Okay. So we're going to go into Tableau at this stage, assuming you don't have any questions. Okay. And we're going to pull in the data file called time series COVID confirmed US. This data set can be pulled in from the file options out here. As you get familiar with the environment, let me give you a quick tour of what you're seeing in front of you. Tableau can connect to files on your computer. They could be Excel files, text files, JSON files. It can even scrape a PDF for you. You can pull in an SPSS file, a SAS file, and so on as a statistical file. Tableau is also capable of pulling in files that are on a cloud. By cloud, I mean it could be on a big MySQL server, or it could be an Oracle server. But let me click on more and see what else this pulls up for us. Suddenly we have an overwhelming number of options available where Tableau can connect to Google Sheets, Google Analytics, Amazon Redshift. And if there's some sort of a cloud source you want to link up to that Tableau doesn't have a connection to, then you can create that by using the Web Data Connector. So there's a lot of ways that you can connect to streaming data and online data and bring that into Tableau almost seamlessly. Hopefully that was enough time for some of you to catch up and open up this Tableau file, Tableau software. So at this point, I'm going to click on text file. I am going to unshare my screen just for a minute because I don't want to expose my entire file structure to you. But I recommend you click on text file. I'll come back to this window in just a second. So again, assuming you've clicked on text file and located that file you saved onto your computer, assuming you're working along. Again, no worries if you're not working along. it's perfectly fine to use this as a way to get a glimpse of COVID. So,
Shal, could you say the name of the file again that we're supposed to load?
Absolutely. If this file is, I'm gonna get over here. And so now I can show you my file structure here, or the files on my computer. It's called time series COVID-19 confirmed US, right? I decided not to change the names given by Johns Hopkins to these files, so it really is a mouthful. So we're looking at the confirmed US.csv file. Should you not see it for some reason, you can change the option on the right to reveal all files or all text files. I have a Windows computer, so here's my interface then. So I'm going to click on open at this stage and fire up this file. As soon as I do that, it opens up in a spreadsheet mode. Tableau calls these things connections. When it opens a file, it calls it a connection. I don't know why. Maybe because Tableau is in this sort of futuristic world where they're thinking about linking up with streaming data or live data. As you can see in the top right-hand corner, it indicates this data connection is live. That means if the underlying data were to change, then the data you see in the screen below will also change. Imagine linking up to Twitter and listening to the retweets and tweets in response to our president's thoughts. Well, so those will be, updated dynamically here should you be linked up to Twitter data in live form. Okay, so we have here a live connection to the stage to this data set time series confirmed, COVID-19 confirmed US. In the bottom of the screen, you see we have a lot of fields here indicating the different fields of data that are part of this data set. You can, of course, scroll right using the bar on the bottom to go all the way right and see all the different columns we have in this data set. We have data here on something called UID, ISO 2, ISO 3, which I have no idea what those are. I actually know, but I don't know. Code 3, FIPS, and so on. And then we go into province, state, country, lat, long. That should be obvious what that means. And then you go on to the right, and then the rest should be self-explanatory. Those are dates going from January 22nd, for which we have data, all the way till yesterday. These are the number of confirmed cases in the US, in the various regions of the US for COVID-19. George, I'm going to have to ask your assistance right now to navigate the chat window here. I'm not going to be able to multitask. I'm single-threaded. So here we are looking at a. Sorry, go ahead.
No, I said no problem.
Thank you. So as we look at the, as you scroll across the data, you'll notice go from left to right, it ends at 4:22. That is yesterday night's data. Since we have many time zones, the data collection stops at 3:30 in the, or 3 o'clock or so in the night. Okay. Yeah, so we're going to now have to prep the data a little bit. There's this notion of a wide data set and a tall data set. Okay, we're going to make this wide data set tall, but before that, let's do some simple filtering of our data. Okay, before we can go and do anything with it, we got to prep the data a little bit. So another way of thinking about this is Tableau is not just a pretty face. Tableau is not just a software that makes you nice graphs and charts. It is a pretty profound data prep tool as well. I'm not talking about Tableau's prep builder. Tableau Desktop itself has some pretty good and amazing data cleaning capabilities. So if you click on, if you look at the data set right now, you'll notice under province state, it's a very strange phrase to use. I mean, why not just call it state? Turns out American Samoa is not a state, although it has a lot of our football players are from right there. So what we want to do at this stage is we want to filter out the states like American Samoa, Guam, and so on. Let's do that first. Okay. To filter, we're going to add a filter. If you click on Add Filter, it's going to pull up a window. In that window, you're going to see a couple of different variables we have. It'll start with a lot of dates, and towards the bottom, you're going to see province state. We're going to select province state. Okay, so I'm holding the screen so I can make sure all of you who are trying to run along are caught up. So on clicking on Add Filters, click on the Add button, and that's going to pull up a lot of different variables in our data set. We're going to scroll all the way down and locate the variable province state. Province state is towards the end because these are organized alphabetically. Numbers first, then alphabetical order. If you now click on OK, it will take us to another window, which is going to give us a nice set of checkboxes. And so let's do a little bit of a geography test out here. Maybe you can test your microphone as well as test your geography, or maybe I'll be testing your geography. If you see any place, any region that's not one of the 50 states of Washington, D.C., let me know. See anything in here that doesn't look like one of the 50 states of Washington, D.C.?
Diamond Princess.
Diamond Princess, clearly. Okay.
American Samoa.
American Samoa, great. Okay.
Grand Princess.
So we're going to scroll down a little bit here and find the next set of checkboxes. Indeed, Grand Princess is a ship.
Guam.
Guam is again one of our territories. So nothing else seems to be showing up here in this window. So I'm going to click on the down again and see what else shows up. Let me know if I missed something.
Northern Mariana Islands.
So the Northern Mariana Islands, we'll check that box as well. And anything else you see that's a miss here? Okay, so let me click down and see what else we see.
Puerto Rico.
So Puerto Rico, what else?
Virgin Islands.
The Virgin Islands as well, okay. That I think should cover all of these states. Now, what we want to do is we want to exclude these states or these provinces. What we're going to do here is we're going to go and check this box here that says exclude. When you do that, when you put a check mark here under exclude, you'll notice all those states, all those, provinces that are checked will get a strike through, which is the intent. Okay. So exclude, and they're gone. Now when you hit OK, and if you hit OK again on the next window, you'll notice those provinces are all gone, which is again what we wanted to do. Okay, so moving along, what we can do now is there's a bit more of data prep to do before we can actually go on to the awesome part of making pretty charts. Let's simplify the picture we are looking at right now. So there's something called UID, ISO 1, ISO 2, Code 3. They have some meaning, but at this point, they're not very meaningful to us. So let's just hide them. We're not going to delete them. Again, I don't believe ever it's a good idea to delete a variable. So we'll just kind of hide them so it's not overwhelming. So I'm going to select these columns by clicking right in the top space and selecting all the way to FIPS. And on a Mac, you can do a two-finger right-click. On a Windows machine, just right-click key. On doing so, you'll see this little, these options show up, like rename, reset name, and so on. Navigate to find hide and click on hide. This will hide those first few columns. Again, we're hiding everything from UID to FIPS. Great. So in doing that, those columns are gone. Again, they're not deleted, we just hidden them, which is good. So if you want to ever see them again, you can of course check the box for show hidden fields, and it will reveal those fields again to us. But let's not do that right now. The second thing we're going to do is we're going to highlight these columns that begin from the date Jan 22nd. Okay, so now you want to select a lot of columns together. I'm sure you all know exactly how to do this, but in case you don't, here's how I'm going to do it. I'm going to select the first column and then drag the slider all the way to the end with Shift press down in a Windows machine. I believe it's same in a Mac also. I'm going to select the last column. Doing this will have, you know, the desirable result of selecting all the columns that have a date in them. So again, what I've done is I've gone and to the very first column. I selected the first date column, Jan 22nd. Then I went to the last. I dragged the slider all the way to the last column, and with Shift press down, selected the last column. This has now selected all of the date columns. We want to now do what Tableau calls a pivot of the data. We want to make a wide table tall. There are many folks who believe, rightfully so, that a wide data set is not amenable to data analysis. You want to make it tall to be able to do a lot of cool things, nifty things. So especially if you've got time as a variable, you want the time variable to be in a column, not in a single column, not along multiple columns. Let's see what happens now if you locate. Again, hopefully we have enough time here to find and select these different columns. If you've selected them, find that, and hopefully I haven't gone off screen. If I have, let me know. I think so. If you now select the down arrow,
You have.
I have gone off screen. Okay, so again, on the very last column, there's really no way for me to kind of, because that pop-up is going to appear off screen. I'll do it somewhere here. Okay, so you want to make sure you select the last columns drop down or down arrow, not the one from the penultimate one like I have done here. I'm doing this only to show you where the pivot option is going to appear. So what you want to do here is go to the last column and then hit the down arrow there and hit the pivot option. This is critically important because we cannot really make the chart we want to make unless we pivot the data to make it a tall data set. Okay, so again, you're going to look for that last column and you look for this pivot option that I have revealed by clicking the penultimate, the one before the last column. Okay, so if I click that, here's what happens to my data. We have now a tall data set because all those date columns have gone into one column now. And all the data associated with those date columns is in another column. So now if you were to actually scroll down to the bottom, it's a very, very tall data set. Of course, Tableau only shows us the first 1,000 rows by default. So hopefully you're all at this stage. Good, all right, great. So in case you missed that part, in case you ever missed something or do something you didn't want to do, there is a way to hit the undo button. Okay, so I'm going to do that undo part and just go back in case some of you kind of got lost as far as this part goes. We'll make sure that you are, you can kind of tag along by redoing this thing. So Jan 22nd selected, going all the way out to the right and selecting April 22nd, and then pivoting the data to make it to just 2 columns. All the information right now in the pivot field names are the dates. We're going to rename that dates pivot field's names column to date. So right click and rename. Now, I'm going to do the same thing with the pivot field values also. I'm going to rename that to be confirmed, to reflect these are confirmed COVID cases in the country. Furthermore, I'm going to go on and rename this third column that says admin 2. I happen to know because I went through the data and looked at the data description by Johns Hopkins that admin 2 are counties. If you're from Alabama, you probably recognize that county that I can't pronounce. Watauga. So rename that to county. At this stage, we have two new columns, and we have renamed 3 columns. So our first column is date, second column is confirmed, third is county, and so on. Province state is really awkward. It's been nagging me for quite a while. So, you know, make me feel better by renaming that to just state. Province state is so awkward. Makes us feel like a colonialist. Okay. Again, renaming country region to just country. Now bear in mind, this is US data, so it doesn't really matter whether we have that country field or not, but I'll show you why that's relevant in a couple of clicks. Okay. Now that we have the variables set up, it looks like a more compact, simple enough data structure that we can kind of look at and make some sense of here. Let's do an incredibly important thing to do here is to be able to parse date. One thing that Tableau so there are 2 things that Tableau excels at in my view. One of them is how it manages, or how well it manages dates, and how well it manages geographical locations. You know, depending on what part of the world you were raised in, the part of the world where I was raised, you know, we call today 23-4-20. Okay, so DDMMYYY. Of course, in America, it's MMDDYY format. Computers like to go YYYY, MMDD, HH, MMSS as their format. So depending on whether you're talking to a computer, an American, or somebody in the United States, somebody in another country, the formats of times and dates vary greatly. The beauty about Tableau is all I've got to do is click ABC and hit date, and it will figure out right away what date format to use. And now when you see the calendar option, calendar kind of icon out there, this is now marked as a date field. It's a very powerful you know, tool, which we'll see reap the dividends of very soon. Now, go ahead.
Sorry, I missed that part. How did you set the date?
All I did was I clicked on this icon here. That was earlier string, and I selected date.
Okay, thank you.
Now, I forgot, I neglected to mention this, but it just occurred to me that just in case your computer is not American. Now, it's not a great thing to be just American or something, but if your computer happens to be not American, then you need to change some things about it. Again, this will not apply to most of you. It'll apply to a very select few of you. If your computer, again, so you select text file properties under the connection, you want to make sure that your locale is English United States. This is how Tableau will know that the default date format in the US is MMDDYY. It'll know that in the US, we separate a number like, you know, we use a period for decimals, unlike Norway, right? This is how it'll know that Alabama is a state in the United States, although there might be an Alabama in some other part of the world, right? So this is why we want to make sure that your setting, especially for locale, is English United States. Again, for most of you, this is going to be the case. Right. So a couple of more things to do before we can move on here into the part about building charts. Click on ABC under the the column called county, and we're going to assign this a geographical role. The second fantastic thing that Tableau does, and I'm going to make sure that you can see this clearly. I'm going to expand my screen a little bit, excuse me, is it's able to figure out, you know, a county, a state, a city, and so on. And by figure out, what I mean is that whenever you supply a county name, it will figure out the coordinates for the entire county. So we're setting the geographical role for county to county. Okay. At this stage, we have globe signs on county, state, and country. We want to make sure that for longitude, this isn't important for what we're going to do here, but I just feel kind of bad that longitude isn't correctly labeled as as longitude. So we can go in and make sure that longitude's data type is also longitude. Right? And I'm saying it doesn't matter because we're not going to use these coordinates that you know, Johns Hopkins has given us in their data set. We'll use ones that Tableau will generate for us. Great. Lastly, there's a column here called combined key. It really isn't adding any value. Let's hide that to simplify our kind of view. Okay. So at this point, here's what I see. Hopefully that's also what you see. Okay. For some of you, this might be really, really slow, and my apologies. We're going to step it up a little bit in a short while. We're not going to go to the stage where we're going to build out our charts. So to build out charts, click on Sheet. Just like Excel, there are these tabs in the bottom. If you click on Sheet, Sheet 1 in this case, it'll take you to the first sheet. And that looks like this. The good thing about this sheet structure is now Tableau is neatly organized on the left are variables for us. You see on the left there are dimensions and measures. Dimensions are discrete, measures are continuous. Let me do one more data prep here and then we'll get on underway. Okay, the one more thing to do here is by default, Tableau has figured out what that little kid, the second grader who came up here a short while ago, would have known, which is a country contains states. But in our data, we had country, state, we had a separate column of county. Tableau is automatically figuring out again, a country contains states, that's a hierarchy. But a state contains counties. Let's put county under state. Okay, so let's drag, we're going to do a drag and drop out here to make sure that this is correctly organized as a hierarchy. So click on county with the button clicked, drag it to right under state. As you do that, you'll see that county will now appear as a hierarchy, country, state, county. This is our way of telling Tableau that a country contains states and states contain counties in them. Okay, we're done for the most part with prepping the data. We're set to build now. On the left, what you see are pills. Tableau calls its variables pills, especially when they're dragged onto the canvas, they look like pills. So let's take a look at what the first pill looks like. Let's drag state over, let's drag date over, excuse me. Let's drag date over to filters. I want to make sure that we are looking at, you know, the right slice of the data. So when you drag date over to filters, you're going to notice this box pop up, this window show up. In this window, we have a couple of options. We're going to hit the next button at the very bottom. And then, as you can see, we have a slider. Let's drag the slider, the one on the left, drag that out all the way to the right so that we only have one date, April 22nd. This way, we're only looking at data for April 22nd. Okay? So again, we're going to drag the slider out to the right such that we only see data for April 22nd and nothing else.
Professor, can you please repeat the step once again?
Sure. Choose one more time. So we go to date. We drag date to filters. Our goal here is to only select the date April 22nd. We drag it to filters. A window pops up that looks as follows. We click on next. At this stage, we can now drag the slider from left to right to only keep April 22nd. So now our data is April 22nd to April 22nd, which was the intent. Okay. Click apply and OK, or just OK is fine. We now have the data selected for April 22nd. Let's go on now and drag state to, let's take it to rows.
Professor, I think I missed something because I cannot see the states in my data.
Say that
Just the
again?
country. Oh, no, I can see it, sorry.
Okay. So we're gonna drag state over to columns. And you notice now states are along the columns. Drag state over to rows, they go along the rows. All we did was drag a variable on, and Tableau now knows how they're going to be organized along rows or columns. Right, so right now we have all the states organized along rows by dragging the state fill over to the rows shelf in Tableau. The next
How do
thing,
you decide which variable goes into a row or a column?
whatever looks better.
Okay.
You'll see, great question, okay? You'll see in just a minute how we figured that part out. So we're gonna now drag confirmed onto columns. To answer the question again, a row bar chart in general, horizontal bar chart, excuse me, looks better in general than vertical bar charts, but it may not always be the case. So I'm dropping confirmed onto columns. Now I see a picture that looks like this. Now, this is sort of a visual process. We're trying to get the best looking picture. So I can swap these pills, and sounds really bad swapping pills, but if you swap the pills, you're gonna get a vertical bar chart. I move it back again, the blue pill goes down, green pill goes up, and right away we've got a horizontal bar chart. So horizontal bar chart lends itself better to comparisons than does a vertical bar chart. I mean, again, it depends on perspective here. Now let's make our picture. What we don't want to do with a chart or visualization is make things too complicated. This is too much information. The exact same problem that a big spreadsheet has. Let's simplify the picture by only revealing the top 10 states. So if I drag state over to filters.
Professor?
Yeah.
Can you please tell me again, how did you get the sum confirmed?
It was always on the left. So I drag confirmed from the left over to columns.
Okay, thank you.
State goes to filters. And this will now give us a new window to select states. And you might be wondering, how do we know which are the worst hit states? Well, you might know. How do you not know? It's New York, obviously. And it's New Jersey, we all know that. But then what comes after that? So we can let Tableau figure that out for us. So we can go to the tabs on top, general wildcard condition top, click on top, and now select the field, select by field. The selected options are top 10 confirmed, sum. That's perfect. We could, of course, have changed this to a different field if we had, wanted to do that. So right now we have top 10 confirmed some. This is going to show us the top 10 states by confirmed COVID cases. Click OK, and we see a simpler looking picture. Let's go ahead now, right on top, and find a way to organize this. Right now, the organization, as you probably figured out, is alphabetical. Alphabetical is almost never a good reason for you to organize your bars or in a bar chart form. You typically want to organize them either in order of size or against some other criterion you might have. If you hover your mouse over the very top of this horizontal bar chart, you'll see this little icon show up. You click on the icon once, and it goes into descending order. Click on it twice, ascending order. Click on it a third time, back to alphabetical. I'm going to go with descending. Now again, that little icon that I'm talking about is right above the bars. So at this point, we have the different states organized here in order of the number of confirmed cases for April 22nd, yesterday. No surprise, New York is the worst in terms of the total confirmed cases, again, for the state alone. Let's bring some more color to this picture. So I'm a big believer in appealing to as many senses as you can. Unfortunately, we're not to a point where our graphs can make noises, sounds, and smell. Someday we'll get there, and touch also maybe. For right now, let's work with the little we have. Let's try and make our charts colorful. So let's bring more color to bear upon this chart. I'm assuming that we are thinking here, bigger numbers are one color, smaller numbers are different color. That's one way we can utilize color to make our graphs or the story pop out much better. So what I'm going to do is drag some confirmed. I can drag it from columns, but then it might just get moved. So there are two things we can do out here. This is, again, if you're just starting out, I recommend moving confirmed from measures onto color and see what happens. Okay. If you're an advanced power user, then here's something cool that you probably already knew, but you can drag a copy of a pill. So if I were to undo this thing, if you can drag a copy of a pill by pressing Command or Control down, Control in a Windows machine, Command in a Mac, and then dragging a copy of that and dropping. This drag and drop is done with Control or Command press down. This way you only drag out a copy and not the original variable, right? So you have that option also available. They both result in the same picture though. This picture is blues. Okay, tribute to the Giants, I guess. But really, COVID is a dreadful kind of condition. So I really want to bring out the story here by expressing it with a color that brings out how bad things are. So you click on the color mark in the marks card, and then click Edit Colors. It'll give us the opportunity to change the color palette to something that is more reflective of the variable we're expressing here. So click Edit Colors, and now I'm going to go with maybe reds from Edit Colors. Now, if we click OK, right away our graph is now popping out much better. We have a picture that shows us all these different states that are, again, colored based on how the severity of the situation. Okay. I'm going to hide this card here. On the right, we have a card that isn't doing much. And I'm going to hide that card by hitting the arrow to the right out here. And we will make that card hidden then. So here's what we're going to do. We're going to go to the right and hide this card because I don't think the legend is actually helpful out here. So Ed Tufte, a guru in database, says that you want to make sure every square inch of your viz is saying something useful. So I'm gonna make that card go away completely. So it's not taking up valuable real estate on the screen. So here we have a nice story popping out already of COVID cases across the country, across different states. Let's bring more to bear on this. Let's try and see if we can do other things with this. Okay, we can do a whole bunch of things with this, but let's work through the process here. So what I want to do is kind of, again, we don't have a whole lot of time here, so I'm going to kind of give you sort of a lay of what we're accomplishing out here. We're really just at the very start here. We're at this stage building a bar chart to filter out the top 10 states for last state. We can easily transform this very chart into many other charts that tell a story. So we can try and build a table, a heat map, a bubble chart, area chart from this point on. Let's take a look then. So this chart looks good. You probably want to preserve this, so let's not disturb this, okay? I'm gonna do a right click on here and say duplicate, and it will make a copy of this, this sheet for us. Now, on the new sheet that's popped up called sheet 1, 2, again, we can rename this something, if you'd like to. Just double click to rename if you'd like to. But I'm not going to worry about that right now. So on this new sheet, let's think about, again, if you think, about data in general, a bar chart, a line graph, a table, bubbles, squares, pie chart. These are all different ways of expressing your data. We want to figure out the best way to tell a story. And if you're into storytelling, you probably know there's more than one way to tell a story. Same with charts also. We have right now a horizontal bar chart. We've already seen the option. We could have easily gone to a vertical bar chart. Well, you can do many other things as well out here. What if you decided you just want a simple table? Sometimes a table is all you really want. So let's try and convert now what we have by default, the automatic selection of a bar chart. Notice it says automatic and its bar icon right by it. Let's try and do something else here. Let's take this, variable or pill called confirmed and drag that onto label and see what happens. Something drastic might happen. We're not dragging a copy of it. We're dragging the entire, we're moving this pill. The green pill called some confirmed, we'll move that and drop it onto label. On doing so, our bar chart is gone. We now have a very simple table that shows us again how serious, maybe this highlights better the fact that New York is 10 times more, worse than Louisiana in terms of confirmed cases. It's easier to see that here than it was with the bar chart. Sometimes all you want is a table. Now, if you're going to build a table, however, it always makes sense to have a table where the numbers tell you something. You can see here, the larger the number, the darker the number. But a heat map is not about darker numbers. It's about a darker background. Let's make that happen then. Let's convert this into a heat map. To do that, we'll go up here to where it says automatic. Notice it says automatic out here, has a down arrow next to it. The selection right now for the color is text. It's coloring our text. What if you want to really color the background? Well, we can click on the down arrow and select from here a square, which will then impose a square in the background and color the square. It'll fill in the square with a darker color to reflect larger numbers. There we go. We got a heat map. So just by moving some pills around, we've gone from a horizontal bar chart to a table and onto a heat map. There's tons more things you can do out here. So let's preserve this. I'm going to go ahead. So I'm going to duplicate this sheet over, and on our next sheet, what we'll do here is we will again see what other cool things we can do with these. Now, there are some things you can do with graphs that don't necessarily tell a better story, but they just seem really cool. Okay, let's do one of those things. Let's drag state. State right now is along rows. Let's no longer use state along rows. Let's just drag state over to, I'm wondering where to put it. Let's put it onto, just put it onto details shelf somewhere here. Okay, we'll put it somewhere in the marks card and just leave it there. We'll see what happens next. Okay, I'm not fully, you know, I don't fully know what's going to happen at this stage. Okay. The drag state and drop it on the marks card someplace, and now our graph is gone. We had a nice heat map, it's all gone, but we'll recover. We'll come back stronger than ever with this. So here we are. All we have is a bunch of squares, and if you think about why there are squares out here, you probably can figure out why these are squares. Tableau decided to select squares, that's why. Let's make that circles. Okay, now we got circles. There are 10 circles. Not very helpful. Okay, now let's drag sum confirmed. Tell you what, let's get a fresh sum confirmed variable, a fresh confirmed variable from the measures, and drag down to size. And you'll see exactly why we're doing this. On doing so, the bubbles will be sized based on how large confirmed is. We've got a bubble chart now. Of course, I have no clue. Well, I guess I do know that the largest one is going to be New York, and the second largest is going to be New Jersey. But I don't know about the other states. Now I could hover the mouse over them and it would tell me what those states are, but the state should be revealed in the bubble. To do that, let's drag state onto label. Now we have both the confirmed cases count as well as the states listed out here. Unfortunately, it seems like this, I feel the number should be below the state. We can accomplish this many different ways. I'm going to try one way that hopefully this is a better solution. I'm going to try and drag confirmed onto label, and hopefully by doing this, it's going to swap the order. It did. So drag confirmed onto label, and now swap the order of state and state and confirmed cases. It looks better this way. Now, bubble graphs are really useful in I guess, shock and awe. They really have very little value because we are terrible as humans at comparing the area of circles to figure which one is bigger, which one is smaller. If your goal is to compare how bad is New York compared to Texas, circles is not the best comparison. Nevertheless, if your goal is shock and awe, let's do that. Let's take state from the filters and throw it out. And now we get all the states in the country. You get to see by looking at this that we should stay indoors. If you're in New York or New Jersey, things are pretty darn bad here. Tableau does a really good job of being smart about labeling. If it feels that it cannot fit a state name into a bubble, it won't put it. So it won't make, you know, labels spill over into other bubbles and kind of make it a messy looking chart. Really good thing about Tableau then. Okay, now this is a bubble chart. Now again, I told you, it's a great magazine cover, a great first presentation slide, but awful for anything else. Many people, I mentioned at the very start, pie charts are a really bad idea, bad way to represent your data as well. So let's go to something else that is kind of a better representation. So you can go here to the down arrow and select square. And now we go to a slightly better, more meaningful representation of our data. What this is going to do is convert the mark to squares. And now we have sort of like a more meaningful comparison. I feel a little more, we are better at comparing squares or rectangles than we are at comparing circles. That's what, you know, these marketers who have been looking at pizzas and cakes have figured out. Right? So we still have the color in here. But again, if we have an area map like this, you really want to be able to, again, convey to your audience, you know, what does 263,000 mean in the context of all these states? Maybe we can convert this into a percentage. So let's do that. Let's drag a fresh confirmed pill onto label. Now we're going to get two numbers, one below the other. You might wonder why in the world we do that. Actually, didn't give us a second one, so never mind. We'll do something else and then get that that thing I was talking about back in. So what we can do here is we're going to go to where it says confirmed for label, and we will do a little bit of math. Okay, we will figure out what percentage of the country 263,000 is, and replace 263,000 with the proportion or percentage. Click on sum, confirm the down arrow, go to add table calculation, and now click on that button. In the window that pops up, select percent of total. Specify. By default, the percent of total is done on state, but I like to specify, click specific dimensions, and be sure that it's doing just that. So it's doing percent of total for the state variable. Great. There you have it. Now, our squares are, you know, our rectangles are reflecting then in the top left-hand corner what percentage of confirmed cases. New York is 1/3 of the problem when think about COVID. In fact, you think about take together New York and New Jersey, that's 42%. So it really helps in storytelling then if you have these percentages built into your chart.
Can you please
Excuse
repeat
me.
that step?
Oh, sorry.
Could you please repeat the step of how it says that you were able to show the percentages?
Oh yeah, so let me hit the back button a few times and kind of navigate backwards. So all I did was oops, that was too much. Okay, let's, okay. So let me just throw this out completely, bring it back on, and we'll make this, okay. So all I did was I went and confirmed the down arrow and add a table calculation. Tableau folks like calling them calcs. So when you add a table calc, it's going to give you the option to choose the calculation type. I chose percent of total. The default choice was state, which is good. Just to confirm them, to click specific dimensions and then hit the X button. There we have it. All right, so this is, again, you can do a whole bunch of charts like this with Tableau really easily. Now, I want to be mindful of the clock here. I was reminded by a student that we might be locked in our homes, but we do have lives. So what I'm going to do is I'm going to step into sort of like an accelerated mode at this stage to show you a lot of all the other things you can do with Tableau at a much faster clip. You may not be able to follow along with what I do at this stage. Okay. So in the next couple of minutes, I'll go through and show you, and again, a few things about maybe looking at how things have changed with what Tableau has done for our lives. So we'll do a couple of charts really quickly out here and give you a sense of just that. Right? So look at a heat map, maybe look at a time series chart if time permits, and onto a dashboard again if we're able to get there. So there's really a lot of things you can do here. So let me go again at a faster clip with the first thing, a little heat map type thing. Okay. So the idea of a heat map for changes, let's see if this story is compelling enough for you. And I'll tell you again what we're going to do step by step. You'll have video available with you if you want to go back and take a look at this. So as before, I'm going to go in and start by selecting the top 10 confirmed cases and then say, give me a table of this. So, and give me a table by different dates. So put date on the columns and specify date as being this day out here, which is going to give me a lot of days of the month. I'm also going to filter out dates to only, in this case, use the days of April. So we're only focusing on April, you know, the Fool's Day, the date that I hear Georgia governor learned that people can be asymptomatic with COVID. Yes, it was April 1st, and it's not a joke, sadly enough. So we're going to drag state onto rows and then figure out a way to populate this table. We're going to put in here confirmed cases onto text. And next, I'm also going to go and drag confirmed cases onto, let's say, color, and then we get a heat map from there. This heat map shows us, in a sense, the confirmed cases and how what they are over time, with, again, a background that I don't think makes sense. So we're going to change the color palette to reds. And next, organize or sort the data by state in terms of confirmed cases. So I'm going to choose out here, give me or sort the data based on number of confirmed cases, putting New York right on top of the list then. Now, what we really want to know is not so much about how bad, we know how bad things are. I'm really curious, I mean, everybody around us is curious in knowing, are things getting better? So to do that, I'm going to go and say here under confirmed, give me the percentage change. So show me from one day to the other, what is the difference we're seeing? What is the percentage difference from a previous day? And here's our story. So the story is as follows. We're going to just hide some stuff that seems to be taking away attention. And you can see out here, our coloring, unfortunately, is based on the wrong criteria. I'm going to fix that right now. And back on here. Okay. So here's our picture then. Our picture tells us the following. Oops, I don't know if you can see that or not. I'll make this fit nicer so you can see it better. But okay. Oh, that looks crammed. Okay, sorry. So as you can tell, I'm kind of figuring out a way to make this look better. A lot of making charts is about trying to figure out a way to make the numbers fit, make them look really good. So the packaging makes a big difference here. So I've removed decimal places out there. So now we have just the numbers out here. And as you scroll left to right, you can see the percentage day by day increase in confirmed cases. These are confirmed cases. They cannot go negative. They can only go up. The question is, has the growth slowed down? Louisiana was a scary place on April 2nd, where they had a 42% growth in cases. For most states, though, we're seeing a nice decline in cases from day to day. That is, the acceleration, the rate of increase has slowed down over time. Another way of expressing the same thing, probably a more common way of expressing this, would be to use something like a time series graph. So maybe you want to think about here how things changed over time for the different states. So we put the states out, well, let's see, put date on the columns and express date as a continuous variable. Drag confirmed cases onto rows. And let's now, again, only check the top 10 states status, excuse me. Okay. And see what this looks like. And then we'll drag state over to rows. That was really, really fast, I know. But you get a sense now of these are the graphs of different states. I'm going to sort these based on, by descending order, so you can see where New York sits in this picture. Here are the confirmed cases, and let's look for the flattening of the curve. It's really hard to see compare these graphs for one reason, because there are too many. There are 10 of them. I'm going to cut that down to 5. The second problem with the viz is that they're on different scales. So New York has a lot of cases. I'm going to synchronize the scales by saying edit axis and specifying independent axis ranges. So now we're focusing on different states and being able to compare them meaningfully. Here then are the graphs showing you the flattening of the curve or the lack of it. Okay. So you can see again very quickly out here how you can look at these states and see how things are changing out here. Now, some people like things that move around. Things that move around grab our attention. They're not always the best thing to present your data, but you can do that if you'd like to. So let's try and do that here by dragging date over to pages, and we'll try and make a picture that moves around. Tableau can do this quite easily. In fact, many software can do this, not just Tableau. We'll try and make this, really tell a story. So I'm going to drag this over to bar, and let's say we drag some confirmed over to color using the same palette as before, which is reds. Okay. And now let me click on the play button. Hopefully I did everything correctly. A few cosmetic, cleanups, and this will look better then. One can go on forever cleaning up the table like this to make it look clean. But I like to do these things to make it look cleaner. It's nicer that way. Okay, so here we are. Okay, so I'm gonna hit the play button now and we'll watch the story play out. So as you go from left to right, you notice that the clock on top is clicking. It's ticking, Jan 28, 29, 30. And I'm gonna speed up the pace a little bit here. And as you can see, we're getting to Feb 4th. There's nothing on this graph paper. If you can't see anything, it's not because of your eyes, because we were in a very happy place in February. Maybe it was ignorance because of lack of testing. Or maybe really there was nothing back then. And on Feb 17th, 18th, we're going on with our lives as though nothing had happened. We looked at China, looked at Italy, and showed sympathy or pity for them. And as we approached early March, people like me were freaking out wearing gloves in the train, looking really silly. And around March 4th, March 5th, I think is when we started to see some things happening in here. Right. This is one of those situations where you set something up, tell a story, and nothing ever happens. It's one of those cases. Wait, it's happening. Okay, you see the bars? Okay, so we start to see now these bars popping up higher and higher as time goes along. Let me hit the stop button here and make this picture a little better by sharing a bit more information here about the process. So it'll tell the story a little better if we can look at the history here. So let's drag the slider back a little bit to the nice days when we could be outside in March to how things are now. And I'll speed up the process a little bit. And so you kind of see how bad things are and how bad they've gotten over time by animating the graph out. Again, it didn't take rocket science, or it wasn't too complicated to make that thing possible. We can do a whole bunch of different things with this data here. I'm going to do one more thing and then we'll quit. Okay, so what I'd like to highlight here is, again, how things changed with COVID. One of the things that has changed is our behavior. I found some cool data by Google in their Google Mobility Report. What they do is they take a bunch of data from people's smartphones, those who've got their Google Maps app on, and allows them to then to share information about where they're located and all. So hopefully I can pull this off in the next minute or so. And let me see if I can do this. So I'm going to try and get data here for United States and show you again based on Google Maps data, how our behavior in this country has changed. So this is a fresh data set, so it's going to look a little different. Tableau can manage many different data sets at the same time. We have here state data, And we also have county level data here for these different places. So here's the county level data. Let me make sure I said county here. And data is in a nice format. We here have data on things like we have data on retail and recreation, grocery stores, pharmacy, and so on, where people were based on some index. So having this data loaded up, I'm going to go in and now build out a little graph. Maybe we can then piece them together in lightning fast time. So putting up a graph here for the different activities we've been engaged in. So let's see, workplaces, right? So this is information about workplace, time you're spending, and use average here to average across counties or states. And here we are. So here's what has happened to our lives since COVID-19 as far as work is concerned across the country. Okay, so here is again a graph that's showing us, we'll clean up, that we're spending less and less time at work, which is being revealed by this graph, the big drop you're seeing. I'm going to color this and then move on to another graph. Okay. Okay, so we have here one graph that's showing us some information about how things are changing over time at the workplace. Leave this actually. Leave this default color. Okay, so let's call this work, and I'm going to make a few copies of this thing, and we should be able to finish up with a dashboard in just a minute. So I'm going to do the same thing right now for another variable we have data on, which is what people are doing. Are they going to work? Are they traveling to work or not? Hopefully they're not, right? So we're going to say out here, average for this variable as well. And this is about travel to work. And the third chart coming up, which is about, are people going to shopping? Has that behavior changed or not over time? And this is showing us retail behavior of people. Are they going shopping or not? And lastly, we got a graph here of, are they staying at home? So again, this is based on figuring out people's phone use in their home. Has it gone up or down? Excuse me. And let's put this together. And this is called home. A dashboard is a place where you can put all these things together, right? So here is a picture then to wrap up our session here of what people are doing and how our lives have changed following COVID, right? So make this fit a little better into a screen. Make the laptop browser. There you go. So a dashboard then is kind of a summary of all the activities we're seeing. You can see right now, based on what Google Maps has been tracking about people, on a scaled basis, we're spending less and less time at work, less time traveling, less time in retail recreation, and much more time at home following COVID. Okay. If you will bear with me for just one more minute, there's one more thing I really think would be kind of cool to add out here, which would be to figure out, well, how does this vary based on where we're living? So let's add on here two filters here, one for state and one for county, and reveal those filters. And we'll kind of put them in the dashboard as well. So putting in two filters here, one for county, one for state. So you can then choose from a set of options to select for a certain place how things are. And we'll go back over dashboard, drag work in here. Great. So now we have in this dashboard an ability to filter our data by state and county. Great. So as our last thing we're going to do here, anybody want to select a state and a county you're going to look at, see how our lives have changed?
New York.
What state? New York. Okay, of course. Okay. What county?
Queens, because it's the epicenter, right?
The Queens. This is the thing about data, right? So we actually don't have data on Queens because of how the data is being gathered. I don't believe anything's going to come up. It did come up actually. So sorry, Google has data. So if you look up Johns Hopkins data, there's no data on Queens. They have put all the data into New York. Like New York is like one big county, not realizing New York's 5 counties. But this is Queens. This is how life has changed in Queens. And if you can look at, Brooklyn, which is Kings County, you can of course start typing Kings County out there. You'll see it's Kings, not King County, right? Kings County. So you'll see again in Kings County how things have changed, how life has changed. We're seeing about, does anybody have a Florida county you want to kind of pick out for me? Where people are going to the beach, I hear?
Washington, maybe?
Oh, is Washington a county in Florida or?
Marion County is in Florida.
Which one?
Marion, M-A-R-I-O-N.
Yeah, Monroe, Dade,
Is that
Broward.
Marion or Marion? Marion, okay, great. So here's how things have changed in Marion. So I guess if you look through a lot of these graphs, what I learned was that even if the people are smart, red or blue, whatever their governors are, however they're voting, people are being smart across the country, even if their legislators are not being. People have decided to hunker down and stay home. They've stopped going to work, they've stopped traveling, and they're not going out in rec places or shopping across the country by county. We've run way over time, so I am going to kind of hit the stop button on this on here. And if you have any questions, I'd be glad to take them. I'll just leave that up there. Okay. Tableau is obviously, as you've seen, a great tool if you want to take some data, put it together, prep it, transform it, throw together charts. In a very short period of time, in just a couple of minutes, you can spin together a pretty impressive set of charts. And we have barely scratched the surface of its capabilities.